Okay, folks, we are now going to be in chapter 8 still, but now we are in section 8-5. This is recording number 1. Okay, I might drive some of you crazy by always looking back at this table of contents, but I believe it's very helpful to keep us all oriented about where we are. So what we've done so far is testing for a mean, then we tested for a proportion. Now we're going to talk about the chi-square test for variance or standard deviation. Now keep in mind we're in chapter 8. So remember, chapter 8 is where we are comparing a sample to a population. Chapter 9, we're going to be comparing a sample to another sample. Okay, so this section here, 8.5, we're talking about looking at a variance or a standard deviation. Now remember, if you know one, you know the other. The standard deviation is just the square root of the variance. We're going to test for a variance or a standard deviation. What that basically means then is we take a sample from a population and we say, hey, is this sample the same as the population, or is it totally different? Is it a statistically significant difference between my sample and my population? And that's exactly what we've done before. That's what we did for the mean. That's what we did for the proportion. So it's the same idea, but variances are a little bit harder to wrap your arms around about what does a variance really mean. Okay, so before we use the chi-square distribution and we use it for the confidence interval, okay, here's a review. I'm going to let you read that yourself if you don't mind, okay? And basically, we're going to do the same thing as we've done before. You know, we're going to be using the table to help us figure out all these things, okay? Now, the hard part, this one's a little bit harder because we use table G, and there's 3 different cases to consider, okay? We have to find the critical value for a particular alpha if the hypothesis test is right-tailed, if it's left-tailed, and if it's two-tailed. So it's going to be a little bit different, but you'll be able to do it, no problem. Okay. The table is set up so it gives the area to the right of the critical value, okay? So if the area is right-tailed, you just use the area under the alpha value for the specific degrees of freedom, okay? If it's left-tailed, then you have to do this 1 subtract the alpha, okay? All right? And then if it's two-tailed, you know, you do the usual, the alpha over 2. Okay, so let's take a look. I'm sure you'll get it, no problem. Okay, and for your convenience here, I got the chi-square table right here. Okay, oops, sorry. Okay, so we want the degree of freedom. I lost it. Here it is. 10 degrees. So here's my 10 degrees. You see how much easier this is to use a book? So here's the 10 degrees, and I want it to be 5, alpha of 5 degrees. Shoot. I want the alpha to be 5%. So therefore, I want to the right to be 95%. So 10 degrees, I go over, boom, right there. 10 degrees, 95% is to the right, so that's 3.940 is what I claim. Let's take a look. Boom, there it is, 3.940. You see how this works? Do a few of these. Do a couple of the exercises. You know, just make sure you get it right. The answers are in the back of the book for the exercises. I'm sure you can do this, okay? I'm going to do one more for you here. This is the little more difficult. It's a two-tailed test. Okay, again, it's find the chi-square value, 22 degrees of freedom, alpha is 0.05, and it's a two-tailed test. So if it's a two-tailed test, that means that the error budget, the alpha, half of it's over here, half of it's over here. So I've got to find the 2 values that give that to me, okay? See, in the t-test and the z-test, the curves are symmetrical, so once you have one, you have the other. So you don't have this problem of, oh, I got to find this one and then I got to find this one. Once you find one, you have them both. Okay, so again, it's 22 degrees of freedom, alpha is 0.05, so I have everything I need to know. Okay, so let me bounce back to the table here, and I'm kind of cheating. I'm looking at my book as I do this because I can't remember these numbers. Okay, so it is alpha, so I want 0.025 to the right, and I lost my I lost the degree of freedom. Give me a second. Okay, so it's 22 degrees of freedom. So it's 22 degrees of freedom. That guy to the right, the guy to the right of being 0.025 is going to give me 36.781. And I'm cheating by looking at my book. That is the correct answer. Okay, so 22 degrees of freedom. I come over here and I find the guy that gives me to the right of that number 0.025. What's that number? That number is, it's so hard to line these up, right here, 36.781, and that's the correct number. Okay, so now for the other side, for this number over here, if I want 0.025 to the left, that means that 97, how much is to the right? To the right is 97.5%. So it's 1 subtract 0.025. See, I can't do the arithmetic in my head, unfortunately. So it's 1 subtract 0.025. So that gives me 0.975 to the right of this smaller value. So 97.5 is right here. So 0.975, and the degree of freedom is 22, so that's 10.982 is what I get, and that is the correct answer. Okay, so believe me, it's easier to do it with your book than it is to do it for me to try to do it bouncing between the screens. It's not as hard as you might think. Okay. All right, so then he talks here about what do you do about this table. The table only goes up to a certain level, so if you have a one by one, it only goes up to 30, then it skips to 40, then it skips to 50, then it skips to 60, and then later on it really skips. Well, the reality is everything's on the computer nowadays, but to use this table, he explains how you do this. Okay, so when you're doing the table, do it this way. All right. Okay, so when we're testing a claim, as always, there's a right tail test, a left tail test. There's nothing new there. Okay. All right. So this seems kind of redundant with what we've already talked about. So I'm going to let you read that. Okay. In any event, here is the formula that we're going to use. That chi squared is equal to this. Okay. And then this is the explanation. What is n? What is s squared? What is sigma squared? And so forth. Okay. So we're going to see how this works here very shortly. As always, we have certain requirements. The sample has to be randomly selected. The population must be normally distributed. Observations must be independent of one another. So no big deal. Okay. All right. So we have to do all the normal stuff. I'm going to let you read this. You state the hypotheses, identify the claim, find the critical values. Everything is exactly the same as before. Okay. So here we go. How about an IQ test? The psychologist wishes to see if the variance, now you got to keep it straight, which is variance and which is standard deviation. He says variance. The variance in IQ for counseling patients is less than the variance of the population. So here again, this is chapter 8. So we're taking a sample and we're comparing this sample to the population. The sample size is 10. There's 10 patients that she has. The population variance is 225. The variance of her patients was 206. So she thinks that that's less. She thinks that 206 is less than 225. Well, obviously it is, but is it significantly different? Is it possible that it is explained just by chance? So our null hypothesis is that variance is 225. Our research hypothesis, or our alternative hypothesis, is that it's less than 225. So we're going to do a one-tail test. It's a left-tail test. It's going to be, here's what the cartoon looks like. We're going to be over here, and we're going to decide is we or is we ain't in the critical zone. Okay? And so it's a left-tail test. Alpha is 0.05. That was given to us up here somewhere, 0.05. So we got to find the critical value. Remember the critical value. The table always gives us the area to the right. So let's see if we can find that real quick. I'm not going to rely on the book. I'm going to find it myself. Okay. All right. So give me 1 second. Oh boy, what did I just do? Okay, so give me 1 second. Okay, so in this problem, the n, the number of people in her sample, is 10. So she got the numbers, data points for 10 of her counseling patients. So therefore, the degree of freedom is 9. Alpha is 5%. So when we do our little curvy thing here, we want it to be 95% to the right of the number that we pick. Where's the number we're going to pick? Right there. So degree of freedom is 9. Up the column is 95. So it's 3.325 is what I claim. Let's take a look. There it is, 3.325. So that's our critical value. So draw your critical value, shade in the area, and doggone it, you better do that. If you don't do it, you're going to be sorry. I'm telling you, draw these cartoons. Okay, so we've now got the critical value, 3.325. And now we just crank out the test value. Write down the formula. Here's the formula. Write it down. Then you plug things in. You plug it in, and this is what you come up with. Okay? Now, 8.24 is right here, whereas the critical value is 3.325. That's right here. So you are not the test value that you computed is not in the rejection region. So you do not reject the null hypothesis. So there is not enough evidence to reject the null hypothesis, so there's not enough evidence to support the claim that the variance is less than 225. Okay, so I swear to you, it's not as bad as it looks. The tables are a little bit different. You just got to remember on these tables, it's always the same thing. Oh man, the table is always giving you the area. Okay, now I'm getting frustrated. The table is always giving you the area to the right of whatever this number is. If you can just remember that one little thing, then everything comes, your intuition will save the day, okay? Like I've said before, I don't think it's appropriate or useful to memorize formulas. It's too hard. Human beings can't do it. Okay, so here's the same idea. We got this outpatient surgery. We got the data. We're gonna do our own calculations. Just use a formula or use a calculator. But it's the same exact idea. But this time it's a right tail test. So that the question is, the alternative hypothesis is that sigma is greater than 8. Okay. And this is sigma, okay? So sigma is greater than 8. So make sure when you calculate this, you calculate the standard deviation, not the variance, okay? So when you get the standard deviation, though, when you calculate it, you square it in order to get the variance. So there it is right there. Okay. All right, so you come up with all this stuff. The only hard part about all this, I mean, this is just a formula. You can do that in your sleep, right? This right here is the only hard part, is finding the critical value. Well, what do we know? We know that it's going to be an alpha of 0.10. We know that 15 days were selected, so the degree of freedom is 14. So the critical value is the appropriate critical value, the appropriate chi-squared for a degree of freedom of 14 and an alpha of 10. It's a one-tailed test, so I think that's going to be very, very simple to calculate. Okay, so it's a degree of freedom of 14. I look up there, my alpha gives me the appropriate column. I want 90. I want it to be 10% to the right, so that looks like it's right there. 14 degree of freedom. If I had my fingers on the screen, I could do this better. So 14 is a degree of freedom, and alpha is 10%. So 21.064, I claim, is the appropriate critical value. There it is, 21.064. When you do the calculation, which is just plugging things in on your calculator, you get 27. So 27 is more than 21. So you do reject the null hypothesis. Okay. All right. I got to do one more video here. I can't get this done. So let me stop this video now.